Hi guys, so here we have dividing complex numbers. So we're calling it dividing complex numbers, but really if you look at the example here, this is the way that this is mostly asked in exams. So express 6 plus 2i over 2 minus 3i in the form a plus bi, so in the form of a kind of a normal or natural complex number. So we've got two steps here. We're going to find the conjugate of the denominator, so always the denominator, and that's the number on the bottom, or the complex number on the bottom in this case. And then we're going to multiply top and bottom by this. Okay, so we're going to multiply top and bottom by the conjugate of the bottom. So the bottom complex number here is 2 minus 3i. Therefore the conjugate of that would be, so if you're not sure what conjugate means, then just have a look back. So it's something you should have seen before. It would be 2 plus 3i. So you can just see here, obviously, anyway, that it's just where you change the sign in the middle. So conjugate would be 2 plus 3i. Then we're going to multiply top and bottom. So I'm going to take the 6 plus 2i now over 2 minus 3i. And we're going to multiply the top and bottom by this, by 2 plus 3i. And it's a trick basically that is going to mean that we get the number in this form. So 2 plus 3i over 2 plus 3i. So the reason it's a trick is because if you just take a look at that for a second, 2 plus 3i over 2 plus 3i, really anything over itself, for example, if we had 15 over 15, that's the same thing as 1. So anything over itself is the same thing as 1. So in this case, 2 plus 3i over 2 plus 3i, that's just the same thing as 1. So really, we're just multiplying the complex number, or the 6 plus 2i over 2 minus 3i. We're just multiplying it by 1, really. But by multiplying it by the conjugate of the bottom, it's going to change the form of it. So let's do it. Let's multiply out anyway. So on top, we're going to have 6 plus 2i multiplied by 2 plus 3i. On the bottom, we're going to have 2 minus 3i multiplied by 2 plus 3i. So multiplying out numbers by each other, multiplying out complex numbers is something that you should have looked at before. So if you're not sure of what we're doing here, then take a look back. So on top, we're going to do 6 by 2 plus 3i plus 2i by 2 plus 3i. On the bottom, we're going to do 2 multiplied by 2 plus 3i minus 3i multiplied by 2 plus 3i. So multiplying out the top, then we're going to get 12 plus 18i plus 4i plus 6i squared. On the bottom, we're going to get 4 plus 6i minus 6i and then the last part will be minus 9i squared. So you should know from before that I squared is the same thing as minus 1, so I can just put a minus 1 in instead of the I squared there, and I can put a minus 1 in instead of the I squared on the bottom as well. So we're going to get we're going to get 12 plus 18i plus 4i minus 6, because when we change the I squared to a minus 1 multiplied by 6 is minus 6. And on the bottom, one thing we should be noticed straight away here is that the plus 6i and the minus 6i, they'll just cancel each other out because they're just going to be 0. And then we're left with 4 on the bottom. And when we change the I squared on the bottom into a minus 1, then minus 1 multiplied by 9 minus 9 would be plus 9. So we're just going to get 4 plus 9 on the bottom. And then it's beginning to look a little bit nicer. So 12 minus 6 on top would be 6, because we're just putting the real parts together now, and 18i plus 4i would be 22i. And then we're almost finished, so that's our answer really. You can divide 13 by both of them, so 6 over 13 plus 22 over 13i. So that's a complex number then. That's in the form a plus bi, like what we wanted. So if you take a look back up here, what we've actually done on the bottom, it's actually a trick, because it's always going to work out like this. By multiplying by the conjugate of the bottom, it'll always work out where you get just a number on the bottom, and then you can divide it in easily. So that's why we multiply by the conjugate on the bottom. So obviously you're always going to get an I squared at the end, so that'll just turn it into a number, a real number, and then the 2 in the middle will always cancel out because you're multiplying it by the conjugate, because if you think about it, that's just the way it works out. So if you want to try this one, then just pause the video there and have a go at it, and then play it on, and I'll put up the answer. So you're going to multiply by the conjugate on the bottom, conjugate of the bottom first. You're going to multiply top and bottom by the conjugate of the bottom. So the conjugate of the bottom here would be where you change that plus into a minus, so it would be 3 minus 2i. So really what we're going to do is we're going to do 4 minus 3i over 3 plus 2i multiplied by 3 minus 2i over 3 minus 2i. So on top we're going to get 4 multiplied by 3 minus 2i minus 3i multiplied by 3 minus 2i. And on the bottom we're going to get 3 multiplied by 3 minus 2i plus 2i multiplied by 3 minus 2i. So on the top we're going to get 12 minus 8i minus 9i plus 6i squared. On the bottom we're going to get 9 minus 6i plus 6i. So we see here again the minus 6i plus 6i are going to cancel each other out, and then minus 4i squared. So straight away you can put a line through both of those on the bottom. That's always going to work out as long as you've multiplied by the conjugate. Top anyway will be 12 minus 8i minus 9i, and then that I squared is going to turn into a minus 1, so that will become minus 6 when it's multiplied by the positive 6. The bottom will just be 9, and then that I squared on the bottom will turn into a minus 1, and when you multiply that minus 1 by the minus 4, it'll turn into plus 4. So on the top we're going to get 6 and minus 17i, and that's all over 13, because 9 plus 4 is 13. And then again we can just divide 13 into both of them, so 6 over 13 minus 17 over 13 I, and then that's our final answer. So that's in the form a plus bi.